Hello, I am the author of Rust Code. It's a Rust compiler module which allows you to compile Rust code into assemblies. So in this video I'm going to quickly talk a bit about what I have been working on this week. And also I'm going to be working on some more debugging tools because the project is currently still very much in development and I am on a handful of bugs. There are a lot of them to be squished, so I need to have a good arsenal of tools to allow me to deal with this little bug infestation quickly. So first of all, a little allusion to the last video. I have found out the exact cause of the buffer overrun in the compiled code. Here it is. It's a really simple and stupid mistake. Basically, I should have 1 here and I had 0 here. What did this change? Well, this particular piece of code, as you can see, is intrinsic, so it's an implementation of a built-in compiler function. This function is called pointer offset from one side, and it basically calculates the distance between 2 pointers. Because I had a 0 there instead of a 1, instead of calculating a distance between a pointer A and B, I was calculating a distance between a pointer and itself, which is always 0. Because of that, the Rust formatting code I compiled did not calculate how much data it copied properly, because it always thought that it copied nothing, because this function returns 0. And because of that, it kept copying data and corrupted other memory and caused a crash. In this week, I also have worked a bit on support for 128-bit integers, because there are a lot of bugs there, because 128-bit integers are a bit different in .NET. 128-bit integers have been added a bit later, and because of that, they are special. You can't, for example, if I open the function I used to compile adding 2 integers together, here it is. As you can see, here for floating point numbers, for odd sign and unsigned integers, I use this operation add. I just basically, check that I use this operation because built-in .NET add operation. For 128-bit integers, I'm calling the op addition method because they were added later and they are using operator overloading. They are not built-in types. Kind of interesting. So there were a lot of small bugs related to the way I handle them, related mainly to them being constant 128-bit integers in Rust were not properly translated to .NET constant 128-bit integers, and operations on them also were not all of them have been changed to account for this difference, so that caused some issues. I have also been working on getting the project tested with Rustlantis. Well, what is it? It's a tool that's used to test, for example, the Rust compiler. It has detected some quite interesting bugs. Like here you can see it's quite good at finding bugs in both the Rust compiler and the LLVM backend. And it works by generating a random Rust program, which is then compiled with optimizations and without optimizations, and it's compiled for different targets. It's all with different codegen backends, and it's also run in an interpreter. And because of that, it can detect bugs. And I have been working on getting this thing to test my codegen backend, because, as I said, it's infested with bugs. And I would like to squish as many of them as I can. And this is basically like an atom bomb for killing those bugs. it will basically, since it creates a lot of random Rust programs very, very fast, it finds all of those bugs quite quickly. There is also one thing still needed here. If you look at a file generated by Rustlantis, I have one generated here. You can see it's quite long. Basically, today we're going to be working on minimizing, but I also want to return quickly back to Rustlantis. What they do to allow it to run with my codegen? I basically allowed it to use the C built-in printf function instead of the standard Rust formatting, so it now works in a environment where there is no standard Rust library present. So I technically speaking have a Rust standard library, but it's very broken because my codegen backend is very buggy, so it would be not reliable and it would not be good for testing. So I prefer to just basically I pass through all calls from printf to the C library, and because of that I can be sure that my formatting works perfectly. I'm currently working on getting those changes which allow for using printf instead of the built-in standard Rust formatting upstreamed. I should probably have that done by next week. Okay, so what are we going to be working on now? As I alluded to, this file is quite long, convoluted, and hard to read. If you are familiar with Rust, this may look very weird to you because it's not Rust, it's Mir. Mir is basically an intermediate representation. It's an internal representation of a Rust program used within the Rust compiler, and Rustlantis generates Mir. If you can see here, it's 4,000 lines, so it's very, very large, and I'm not exactly sure which line causes my issues. I can quickly show you what kind of issue happens. Basically, a null reference exception, which means that the reference a null pointer. I have pinpointed where it is the reference, but I don't know why it's here. So in order to make my job slightly easier, we want to make this broken test example as small as possible. How are we going to do that? We are going to remove some lines from the test input. This particular algorithm I'm going to be using is very similar to what Rustlantis is already using, but I have some slightly different requirements regarding to how my compiler module has to be loaded, regarding how, because it's not a built-in Rust compiler module, it's like I have not got my project apps merged with Rust C. It's not going to be happen for quite a while, so it's not shipped with the Rust compiler. You have to load it and set some special configuration options in order to tell the Rust compiler, hi, I would like you to load this compiler module and use it to generate your to turn Mir into native instructions. In my case, those are not native instructions but .NET assemblies. So how are we going to minimize it? Well, we are going to remove lines, and we are going to check if first of all, if the test still compiles with the normal Rust compiler, and second of all, if the difference between behavior between my module and the Rust compiler still persists. I feel that's a relatively straightforward task. So first of all, I will disable statement tracing. Statement tracing is a debugging feature I have in my codegen, which basically makes it insert additional instructions which print which Mir statement is currently being executed. It's very, very useful for debugging, but it will pollute the standard output. It prints additional data that's not printed by the standard Rust compiler, so we'll disable that for now. And now when we rebuild this test example and run it again, it should be, it should only print what the version compiled with Rust would print. I have the version compiled with Rust It's a standard Rust here, and you can see it just goes slightly further without crashing, but up to this point the numbers are all the same. That's kind of a good sign, because it means that there are not that many bugs, but there is a bug still somewhere. So here I have a skeleton of the program we will use to minimize. For example, I have hard-coded some values which will need to be exposed to command line later, but for now that should be good enough. Basically, we load a file and we separate it into individual lines, and we are also able to remove a line. If we now run this tool without, okay, so for now we will run it without removing any lines. It will basically produce the exact thing it got as its input as its output. You can see like this file is identical, but we can, for example, add a function remove line, moved, and when we set this to true, it will remove this line from the file it outputs. In this case, it will remove the oh, I didn't do it. Okay. We can post file line. I don't know, remove the line number 0, so the first, very first line. Oh, that exists. I thought create new would delete, but I'm maybe wrong. Let's check that. Correct. Okay, so it's everything is working correctly, and if we compare this, you can see we have removed this top line. So basically, how it's going to work, it's going to go through every single line of the program, and it's going to remove them if they are not necessary to reproduce the bug. So we'll have a function called try remove line, which will accept our reference to self line to try and remove, and also closure, which will take in an immutable reference to self. And we will return a value which indicates if this line can be removed or not. So we'll basically do self.remove line, or add line. We'll basically do the opposite of remove line. Okay, maybe we'll name it restore line. So this will basically first remove the line, then call the test function with a reference to self, and if this line cannot be removed, then it will add it again. Restore the line. Once again, really simple. You can replace this with a try remove line and add a closure that will test this. Add a small. If we here return true, then this will return this line. This will so here this will now remove the sign, but if we return false here, this will not remove the line. Okay, really simple. So we can also automate that. We can do try remove lines to basically iterate through all lines that have not been removed, and then it will if the line can be removed, then it will remove it. Once again, really simple thing. I am moving this line kind outside of this for loop because we are going to be we are going to be borrowing this value mutably inside of the function, so I can't have that here. Okay, so if this line is not removed, then try to remove it. That's very simple, straightforward. But in the end, when we implement this testing logic, it will be doing wonders. Try remove lines. We can now remove this line argument, and this for now will remove everything because I've removed everything. Your issue value. Oh, I have renamed this to index. Yeah. Oh, I should put a reference to closure instead of a closure. Always be able here, and because of that, this, as you can see now, it's completely empty. And now we can add some simple checks which tell us which lines we can safely remove and which we can't. So basically, first we'll write this file to the target path, and then we'll invoke the Rust compiler to try and compile this file. If we can compile it, then it means that this line can be removed, and if it can't compile it, then it means that this line cannot be removed. I will test. Yeah, here are my test harnesses. They basically invoke the Rust compiler with all the appropriate flags. I will basically only code from here. And we'll have to simplify it. Flags out. Okay. Addition specified properly. So here should be the path of the file. The output path. Irrelevant for now. The default one chosen by the filer should be more good enough. Yeah, basically all we need to specify is the source file and the version of the Rust compiler and stuff. This also is going to quite likely take some time, so I would like to print some stuff here. For example, trying to remove line number. Okay, and now when we are passing absolute path, so the directory doesn't really where is- Oh, yeah. Okay, now it should all work. Okay, so as you can see, it tests every single line, if it can remove it or not. Not the fastest thing in the world, but as you can see, it's slowly. Oh, I'm not checking if the output is. I should now check if the Rust compiler has returned any errors, because if it has returned some errors, then it means that we can't minimize this particular. There is still some more issues because warnings get printed to the standard error. It makes sense to think about it, but it means that we can't just use the naive approach of checking if the standard exit is empty, if the standard error is empty. If we call the Rust compiler with this broken minimized example, we'll see that it will return us an error. So the word error will appear somewhere. So we'll basically check if the output contains the word error. And if it contains the word error, so here we can remove this. If it contains error, then we can't minimize, but if it doesn't, then we can minimize. So this should, if we run this whole thing now, it should slowly remove only those lines which it can remove. Oh, I want to use the phrase error. Basically, once again, this is really a really stupid simple solution. As you can see, it slowly goes through and it removes only those lines it can remove. And it says, for example, okay, I can't remove this line without causing any errors. How much did it remove? This is quite long, quite a long file, so this is going to probably take ages. So I will probably add a limit on the amount of lines I try to remove. Okay, so let's for now, like for testing purposes only, set the line count. Let's make it think that there are slightly less lines than there really are, because I don't have. Like in the future, I could probably spread the workload across multiple threads and do a lot of that fancy stuff, but not for now. For now, all I need is a really simple, stupid solution. And there are some other things we do add in the. Okay, so when it finishes, we can see the differences between the original file and the new file. There doesn't seem to be any right now. Okay, so it seems to have finished. The 100th line is debug, and the 100. Yeah, it seems to have not written anything. Okay, I understand what's happening right now. Basically, the very at the very beginning, I have a bit of code related to printing things to the hill. I think that's something gone wrong, because a lot of those lines should be able to remove them safely. Like here, if we remove this, nothing will happen. There should be no error. So I think I messed something up. Might check. If its standard output error is not empty, then return if it doesn't contain error. Yeah. And if test returns false, then it restores the line. If it returns true, let's print if it contains error. think I messed something up along the way. Because this is a really simple algorithm and it works. Okay. How is error? What are you doing? On this. Okay. Oh, I have re-imported something. Oh, I had an error all along. What's... Oh, I understand. And now... Because basically I... Happening. Oh, I can't save it. Here, yeah, basically I changed this the output of the slant is slightly to make it work better with my testing. That's why this common.rs is included here. It's basically some boilerplate code that makes no SCD programs work in .NET, because like programs built with SCD, but programs built with this without this would and without the no SCD would still work, but they would have some small minor compiler errors along the way which pollute the output, and this basically means that they are 100% correct and there are no errors. Okay, so now it should something. Okay. So there is an error once again. I'm asking. Oh, okay, I understand what's happening right now. Okay, I will just what I was doing previously. I wanted to be sneaky, but I made some changes which broke things, and now it. Oh, nice. Okay, so now you should be able to. Okay, so see, for example, that this line was not necessary. So now when we look at this, yep, it's going to be shorter. As you can see, it removes everything it can. Look at it go. Removing lines nicely. It can. Yeah. So as you can see, it has removed quite a bit of stuff. But a lot of this stuff is impacts the output. It changes the way, it changes what the program would output. So now we'll, besides just invoking the standard Rust compiler to check if everything is correct, we'll do something else. We'll also we also try to compile with my compiler, with my compiler module loaded. So first we'll compile with the standard Rust compiler, and then we'll compile with my stuff and run it inside .NET and check if it failed. And this way we'll have a fully working auto minimizer in like slightly more than 100 lines, I believe, when we finish. So as you can see, yeah, it's a really neat algorithm. It's not mine, once again, but I wanted to rewrite it myself because the one I believe was written in Bash and this in Rust, and additionally there are some more stuff that's necessary to load my compiler module and ensure everything works correctly. Test macro run. Where are you? Okay, so here we like have everything needed, and it even tests the .NET executable. So I will copy everything up to this point, or maybe besides, sorry, because I don't really need everything from here to here. I believe what I need. Around here. Doesn't highlight errors in by section. The Rust analyzer, yeah, it's sometimes never bothered me enough. Yeah. That path probably a path. In the future, those will be generated based on your input, but once again, this is just a rough version of a tool. It will be used by me. Path. Artist. Okay, and now the execute here and good. And if standard output is temp, this is just the compiler. My compiler will complain quite a lot, quite often, so this is not really relevant. Okay, so let's see if this will it's private static, public. I believe I already get the. Oh, yeah, I have a helper function which gives me the build environment. No, but now I'm calling the Rust compiler directly, so I believe I have to pass those. And a piggyback of my testing harness. With pub static ref should work. Build, okay, so it can't find the test path in this. Where do I use test? Ah, yeah, I set it. I don't care. Oh, wait. Function code. Code absolute. Maybe? Yeah, absolute. Bam. Clean. Oh, this is a buffer. Right, then it. Okay, so okay, so now we'll also compile it with my backend. There should be. Maybe we'll panic on error and see. Passing some wrong arguments. Okay, so it's succeeding, but where is my. Maybe I just need to refresh. There is. Okay. So here, oh, yeah, I should change this. If it contains error, then if it doesn't contains error, then you return that this line cannot be removed, and otherwise don't pass through. And it now should. Okay. Unknown unstable option. Happen. I believe. Test. Because yeah, it's because I also have to add this prefix. Yeah, I guess. And now hold on back. That's misspelling. And now. Okay. Okay. So that's irrelevant. Those are the messages I have talked about. They don't change the fact that basically those errors stem from my CodeGen backend not being able to compile the Linux, like the initial. I have not yet specified my own target triple. I'm using the Linux target triple, so the Rust compiler kind of think this is like .NET kind of things that I'm targeting just Linux, and it includes some stuff that's not really relevant. And yeah, when I did not include the file common.rs, it basically contained a lot of stuff that disabled the initialization of the Rust. Because before a program runs, there is some initialization that needs to be done. In my case, I don't use anything from that initialization yet in any of my test cases, so those errors are really irrelevant, and I'm jumping immediately to main. Okay. Almost immediately. There's like another step, but it's related to loading constant data from the assembly on disk into memory. Something that's normally done by your OS, but because I'm targeting .NET, I have to do it manually. Okay, so now I can disable that. And the fact that my compiler returns some errors, it's like, once again, not really what I'm after, at least in this case. In the future, I plan on adding like some more configuration options, probably even the ability to like use something like regular expressions to match for particular errors. But right now, what I'm interested in is if the output executable can be run without using .NET without any issues. Yeah, so we'll basically .NET. We'll add an argument, and it will be basically the executable path, and this should be more than enough. Okay, and now when we check its output, we'll be able to see if there were any exceptions. So if we'll once again do the same thing, if there's anything on the standard error, then we'll pass that, and then we'll check if stdr contains the word exception. In our case, we are interested in very specific exception because we are interested in null reference exception. So if there is null reference exception, then it means that we can further minimize our example, because it means that the error still persists. Yeah, I could maybe be slightly more accurate, like check that it happens in this very particular method in the future. That's maybe something to consider, because I don't want the So if it contains exception and this exception, that should be enough to. If it contains an exception and it's here, then it means that this can be minimized. Else it means that we have changed some behavior and this can't be minimized. Okay, so now it should slowly but surely remove everything that's not necessary to cause an issue. Okay. Because we'll have to be. No, if everything passed through without any issues, then it means it can be. Standard output is not is empty, then it means that everything is going, that there was no issues, so it means that we have to basically, that we can't remove line. Quickly. So basically now we have a simple check, and we remove this. Is like a kind of a generalized algorithm that could minimize anything. You just have to write the right closure, like if something. Okay, so besides that, you're complete. The item return false. If to be returning the funky error. It's that will stop complete. And the weird. Oh. But and should now be able to meet example. And we can see slowly chip away at this file. line by line. And I think way too conservative. Move on. Almost. Let's this. Okay, and we'll also be able to. Now there will be a bit of a deep messaging. I think I have some things slightly mixed. But when that's done, yeah, when I fix that, I will basically have a quite robust. For sure, can remove the very first line. Just erase markers and it's not relevant here. So something along the way goes very wrong. Also, this weird unwillingness to remove anything. Okay, so it's this. There. Check that. Yeah, basically when I yeah, so here it's not empty, and then it says that you can't remove that. Really fascinating. So if it's not empty, then what is it? Oh, don't tell me that. If I remove this, will everything still work? Maybe there's nothing issue. Still. So it knows that the .NET standard it does not contain new reference exception. Oh, that's weird. Maybe let's print it. Yeah. I'm kind of curious. What's happening there? Never reason would that. Okay. Oh. That's fun. Okay, so it can't find the file. Oh, this is my. Oh, I will also have to add something else here. Fix that error. Maybe there was some message. Relevant. Oh, I get it now. In a slightly different place, I guess. Like, okay, if I do that, it will just appear here. Yeah. Oh, I now get it. I now get what's happening. stuff with not yeah. Yeah, I now get what's happening. Basically, I believe it was not exactly the right place because I specified some additional flags. Like those flags, they pass directly through their use for testing, and they place stuff in. There's some additional, like I also set a flag that tells tells my code gen to basically ignore this. To ignore its default, the output it's stored from the command line and place it in a slightly different place. This is needed in order to work with cargo. Because cargo for some reason tells me a very weird, like very long file name that's not really where the stuff should be. So basically, it's kind of a hack to get my compiler back and working with cargo. Like I plan to one day figure out what's exactly happening, but for now, this option is kind of ignored a little. Yes. So probably the names, I don't know, output path. And then change this path to be one level above. Now work without any issues. The runtime should be able to find executable, and it should be able to check if it still fails the exact same way. Okay. Oh, now it's just about the runtime configuration file. This smile file is not really all that relevant. It basically necessary. It tells runtime, I don't know how many GC threads to use and stuff like that. We can even quickly look at what it's all about. The runtime version, stuff like that. Not really all that relevant. Yeah. As you can see, like, I don't know what's the framework, what's the version, I don't know what comment threads are in a thread pool, like that. Not really all that important, but needed, but the runtime will refuse to load anything it doesn't have. Oh, yeah, so we can see that now we have a nice error, and now it should be able to properly minimize stuff. Yes, not return. Wait, why does it go here? Oh, because it doesn't contain this one. Maybe the backtrace is the standard output instead of the standard error. Okay, so it seems to be. Yeah, so it seems like basically this is probably in standard output. Like backtrace. I have a weird choice, but okay. Right. Personally, I would have put it in the standard error too, but I can see there maybe merit to putting it in a separate place. So, or maybe. You just check the name of the. Okay. Oh, because the previous version was compiled with a slightly different compiler version, I believe, because it turns out there was like a small breaking change in one of the APIs, and my GitHub action test stopped working, so I had to update my version too. Okay, let's Okay, yeah. So because of that, the function names change around. Okay, so actually, as you can see, it's not very fast, but it should be able to finish in about an hour. I have one trick up my sleeve to sleep quickly. Basically, a lot of stuff at the beginning completely irrelevant to the test itself. It's just necessary in debug info. And if I add of that stuff to the bottom, it should still work the same, but it should start first removing the less relevant stuff. More relevant stuff. It should first start by, where is it? Okay, so it's 7. Okay. Yep, I removed it. Sorry. Oh, you can see already it's deleting parts of Miru which do not issue. And those were the declarations of the local variables. So now, as you can see, slowly chips away at this file, and it's basically something I can leave running and else. And when I return, I will have a file with the issue drastically minimized, and then I can put it through yet another round of minimizing. And after I put it to a couple rounds of minimizing, I will have a very simple example. It's not fast, but it's good enough for my purpose. Yeah, it goes like a line a second. This file is 4,000 lines, so an hour, and it's mostly done with minimizing stuff. Look at it. Okay, so I feel it's a very good place to stop because I have finished what I wanted to do. So I guess bye. If you like this kind of stuff, driving. If you don't like them, okay, too. You can check out the project on GitHub if you want. I don't know. Just goodbye and have a nice day.